Hi, my name is Chen, and today I'm going to talk about Bayes factor, and this will answer the question how good a feature is to distinguish H1 and H2, where H1 and H2 are two competing hypotheses. A real-life example is given in how good a feature is to distinguish whether an object is gold or not. If we look at the gold and the common stone, we might say, well, we might want to ask whether the object is yellow and shiny, but this will fail to distinguish gold from fool's gold, and we want to ask something about its other physical properties as well. But what if we only have one question to ask? Which is the best question to ask? Is it the physical property of the gold, or the whether it's shiny or not? Let's quantify these things. Now, the quantification will come from a mathematical concept called the Bayes factor. So here we see the familiar Bayes rule, where the posterior probability is a priori probability multiplied by the likelihood. And from this, we can deduce this formula, which is simply divide h1 and h2. And if we define the log Bayes factor as this, then given a list of training examples, we can calculate the log of posterior odd, and in terms of the log of the prior odds and the update caused by odd data. And the higher value of the update, the more useful a categorical variable y is to your update. And we will say in this case that y contains more information than other things. And this quantity here we will define as the evidential value for y. And if we have multiple categorical variables, we can define evidential values of y1, y2, etc. Let's look at an example of calculating it. Suppose we have gender as our y, and we have data as such, then the evidential value of gender is given by this, where we first of all calculate the log Bayes factor for y equals to 0 and y equals to 1. For y equals to 0, we want to calculate the probability of y equals to 0 given that h1 is true, which is 60 over 100. And similarly, the probability of y equals 0 given h2 is true is 30 over 80. And this dividing these two numbers will give us this quotient. And similarly, we calculate all the other things in our previous formulas of evidential values, and we will find the evidential values of gender is 0.1. And if we have some other quantities that we want to ask whether it's more important than gender, we could also calculate the evidential values. And the bigger the evidential values, the more important the factor is. And for more information, we can look at Professor Grandwald's book about mathematical underpinnings of analytics. Now let's look at a more complex example. We have 1,000 data points about attributes about policemen and 1,000 persons that are believed to be thief, and also similar attributes numbers. Here, the first one is age, and we also have some other things. Now, what we want to ask is, what is the best feature that distinguish a police from a thief? And the answer is to calculate evidential value for each of the columns, i.e. for each of the features. The magnitude of them will allow us to deduce the most important factor, as we shown previously. Now, after calculation, we find the following result, and we see that although the age is pretty important, but attribute 2 is actually more important than age. So if we only are allowed to ask one question, we would ask something about attribute 2, and this will tell us the most to tell from apart a policeman and a thief. Can we do better than this? Well, we can. If we combine attribute 1 and attribute 2, we can make a new attribute which has 8 possible values if attribute 1 has 4 and attribute 2 has 2 possible values. And in our previous example, if we combine age and attribute 2 to make a new attribute, then the evidential value of the combined attribute will be 0.1289, which is much higher than either of this. And so in real life, actually, we want to ask something like a combined question of attribute age and attribute 3 and attribute 2. Now let's recap. We use Bayes factor all the time in our daily life. Remember our example of telling the goat whether something is gold or not, and it can be made more rigorous to understand which feature is the best distinguishing factor, and this is called evidential sum. And for more information about the details of examples, please do not hesitate to send an email at this address. Thank you.